Today, this is the second part of the how-to series for Space Engine, or you can also call it the Guide to Space Engine. Today, we're going to be focusing on one specific part in Space Engine that allows you to find any star you will like. If you notice this button here, these dots, this is the star browser. And if you click on this, it gives you this screen. So we're going to tell you all about this screen in a very fast way to make this video as short as possible. So this is the radius. So if it can go up to 326 light years across, light years in radius, and it can't go above that. But what this does is that searches each star within the nearest 326 light years across. So you can see this is about. You can also set the distance, which if you set it up, it'll say the closest distance, which is Ariadne. It turns out it'll probably just filter out some of these stars close by if the higher radius it goes. But that's not the closest star. Proxima is the closest star. Here you can see if you want to have the highest class spectrum stars, which include the giant stars, all the way down to cool white dwarf stars or neutron stars. The distance you can also set this to go to the farthest distance, which is 325.99 light years, which is almost 326 light years. Luminosity goes from the highest luminosity to the lowest luminosity. As you can see, FACT, which is a blue main sequence star, which is the highest luminosity, and the lowest is this, which is a white type brown dwarf. This is just to see how visible it is, from the most visible to the least visible. This is how many stars there are from the most to the least. This is how many planets it orbits the stars from the most to the least, and how many planets that have life from the most to the least. And that is all for this menu. You can set the radius to however you like that. You can go from over 0.3 light years down to 326 light years. So let's give you an example: 50 light years. Scans for the next 50. You can go and you can do all of these stuff again. You can see Proxima Centauri, and now enables them as it's a lower light year, because apparently it can only search up to 10,000 star systems. So you may remove some stars that will not be trapped because it only limits to 10,000 stars. So you can see these. And now this is the star browser's menu screen. Press this button if you want to clear it, and press this if you're going to search for a star. And this one is if you want to enable the filter, which I'll be telling you. This is the filter settings, meaning you can set the star browser to filter however you liked it. So the object parameters, you can set it to the hottest possible down to extremely frigid. And if you want to find a planet with life, search for temperate, marine, and anything between Terra, Carbonia, or Feria. And that's all. If you want to search for habitable planets. If you want to continue getting as habitable as you like, set this from 0 to 10 if you want to have an atmosphere that's actually good for us. Remove tidally locking, because apparently tidally locking is going to affect life a lot. And then set this to organic, multicellular, marine, terrestrial. So you can see organic life there are 4 types of life. 4 types of organic life: and exotic life, which are subglacial, which is life underneath the ice; aerial, which is life above the skies; marine, which is life in the oceans; terrestrial, which is life on land. And this same goes to exotic life, which is life that is actually life that isn't carbon based, like silicate based or panspermia life. And organic life, like a biogenesis life. And here is that. You can set the temperature to however you liked it, from cold to hot, the mass to whatever you like. The higher mass, the more denser it is. The diameter you can set this is by kilometers. So the Earth is about 12,000. So you can see the Earth is about let me get to Earth for a second. Hold on. Earth is about 12,700 kilometers. So if you want to find a planet, so super Earth, anything larger than the Earth, it has to be larger than 12,742 kilometers. Anything below that is going to be smaller. So you can see this one, which shows the Earth radius comparison. Mass is also just the Earth radius, Earth mass comparison index. You can set this to if you want to have clouds or not. I recommend you keep it on like this because apparently habitable planets are most likely to have clouds. You can set this if you want to have your habitable planet having rings or not. It's optional. You don't need that. If you want to have an aurora, just click this correct button. If there's an X, that means it will disinclude this. If there's a correct, it means it will always include it. So this is the star browser menu screen. It also applies to sun counts. You can go from from one sun to 8 or more suns, and planets from no planets at all to at 10 or more planets. You can also see some star types: red giant stars, subgiant stars, main sequence, which is the most common type of stars, subdwarfs, which are not that common, Wolf-Rayet stars, which are also rare, and carbon stars, which are also rare, white dwarf and neutron stars, and black holes, which are star remnants, or that's all. And you can set that for the system's main star, which is the main star for the system, and this is mostly parent for binary star systems, or the parent sun, which is probably a smaller one. So let's say we are going to let me say we set this to default. The system's main star is this, and we're gonna set the system's main star to a G type star, and set this one to, I don't know, an M type star. So let me search for planets that are like this. So it may take some time because apparently it's filtering objects. So it's gonna be taking through some time. Oh, we found some already. As you can see, M type star here, G type star. It's how it works. That's it for the star browser. Thank you so much for watching. Make sure to subscribe. And also you can do the same thing with moons if you want to have a moon. So anyway, make sure to subscribe to the channel. Thank you so much for watching. Bye bye everyone.